Hi everyone, thanks for joining. Just give me a second to toggle on live streaming and then we'll be good to go. We have a very special speaker with us today. His name is Vincent. I would like to call him that he's a AI technical expert and he has an amazing following on LinkedIn. So thanks Vincent for like being a guest with SingleStore and agreeing to do this webinar with us. So today's webinar is really special. It's a different topic and thanks for bringing this to life, Vincent. So today's webinar, like we have marketed that on our website as reducing your database TCO, do more with less. But on Vincent's slides, we see that database scaling, optimization, cost reduction, enterprise AI use case. So Vincent has like a rich experience when it comes to tech. He has seen the landscape shift when it is about the technologies that we are using in the present day database industry. So he's your guy. If there's any technical questions, anything that you're working upon, you have any doubt, we have Vincent live with us today, and he's going to answer any questions that are addressed towards him. And you might see, like, to put your questions forward, there's a Zoom Q&A button which is present at the bottom of your console. You can easily use that to communicate anything with us. And you also might see that there's a chat button. You're currently in a listen only mode, so I will be using that chat button to communicate any form of resources that will be relevant for the session. We highly recommend that you follow along hands on. I will be sharing the link to try SingleStore for free. We are giving away $600 worth of free credits. I mean, it's been like my second year in the company, and I've still not exhausted my credits. So they really last you pretty long. And I like run a lot of intensive workloads. So definitely worth giving a try. I'll be sharing the link with for every resource that is relevant very soon. So stay tuned. Vincent, please take it away. And for my introduction, I'm Yukthi. I'll be your moderator for today's session. So any questions, feedback, or any ideas on future topics, please address that to me using the Zoom Q&A button, or you can always message me on LinkedIn as well. My DMs are always open. If you'd like to collaborate, let me know. And yeah, Vincent, please take it away. Thank you.
Thank you, Yukthi, for the introduction. So, quick question that I have. I'm assuming that it's about like 50-minute live presentation, and then I need to keep like maybe 10 minutes at the end for Q&A and stuff like that. Is that right?
Yes, ideally. It depends on how many questions we have. So, yeah, ideally, that's the thing. Like, we can, if we don't have enough questions, we always end the session early. But if we
Yeah.
have questions, I'll prompt you. Don't worry about it.
Yeah. All right. So let's start then. Thanks again for the introduction. So I'm going to be talking about database optimization, cost reduction. It's going to be essentially the context of enterprise AI, some of the solutions that I've been developing at BondingAI. So it's not just database; it's covering few different things that should be of interest to a lot of people, especially people trying to adopt AI that they've facing expensive costs and all sorts of issues like security, compliance. All of that is related to TCO. I'm going to explain what TCO is about. But yeah, in a nutshell, that's what I'm going to talk about. Before starting, I could do a quick introduction of myself. I'm just going to focus on the last few years, so some historical background that started like 4 or 5 years ago, because it's really very related to what I've developed in recent times in terms of optimization. Otherwise, my general background, I did a PhD in Belgium, did a postdoc at Cambridge, University of Cambridge in computational statistics, worked for a number of companies, big and large, mostly in the United States, like Microsoft, eBay, Wells Fargo, Visa, many times in consulting roles. Self-funded a company, Data Science Central, that I sold in 2020. And then I started to work again on machine learning, NLP, AI, LLM, and that kind of things. So after I sold my company around 2022, I was working on synthetic data, which is a very popular topic back then, especially because of my background in intensive simulation, high-performance computing. I try to understand how generative adversarial networks were working. So data set actually was synthesizing data for enterprise, not computer vision or stuff like that, which is more challenging than images and stuff like that. And depending on the data set, sometimes the GAN, they call it, so generative adversarial networks, that's what they're called, were working quite well, depending on which feature you add or the type of features. Sometimes it didn't work, so it was a hit and miss. I spent a lot of time trying to get a solution that would work for, you know, most data set. In the end, I did a lot of components, pre-processing, different transform, inverse transform, standardization, normalization. I mean, a bunch of different components, and I got something that really worked decently. And my question was, who's doing the job in the end? Because, I mean, sure, there's a deep neural network in the end, but eventually I was wondering if it works because of all the other components that I added around the deep neural network. So I removed the deep neural networks and eventually designed a system that was much leaner, running much faster, better by all metrics, which I called no-GAN because it didn't use those deep neural networks. So that's how things started. And I'm mentioning it because the LLM technology that I'm going to explain in more details, it is the same story behind it. Eventually, there's very little of deep neural networks, heavy training, and that sort of things. So that's kind of how whole things started. So what happened next around 2023, when I was looking for articles, references, there was one particular article that I found like 15 years ago, and I could not find it anywhere. I used Google, Perplexity, OpenAI, a bunch of tools, and it required a lot of prompts. It was very hard to find a precise reference to what I was interested, whether it was that article or something else that would talk about the same topic with a reference that I could use in my article. So I decided there is to be a simple way to extract that information, to find that information on the internet. So what I did back then, I looked at the Wolfram mathematical corpus, which is a well-known for mathematics, computer science, that sort of things, probably one of the best corpus available. There's about 15,000 web pages covering a bunch of topics in mathematics, 5,000 categories, subcategories. It's actually very well structured corpus. So a lot of people talk about, you know, the data that you find on the internet as being very unstructured and stuff like that. But actually, I found it to be very well structured, which also started for me to create stuff that was different from what other people were designing, in the sense that I didn't have to create a knowledge graph or stuff like that. The knowledge graph was embedded into the website and was easy to retrieve. So anyway, I created that first version of LLM that I called XLM to retrieve whatever, links, related items and stuff like that. So the output was not like the traditional output that you see these days, which is called a response. So it was not a chat-like type of application, but it was the results were structured output with a number of sections containing links, section containing related items and stuff like that. So pretty well organized output, which is different from, you know, the ChatGPT and stuff like that. I publish the results. I show how I get much better results compared to even the Wolfram search box or OpenAI. And when I mean better for professional users. if you would looking for something like a random walk, you would retrieve information about three-dimensional random walk, martingales, Wiener processes, and stuff like that. So for me, it was better result. Now for a layman, what you would see might be of little value because you wouldn't understand anything that was being shown to the user. So this is also an important thing to think about, is that the value of what you get from an LLM, it depends very much on the kind of user you are, and whether the LLM is designed for professional users, laymen, and stuff like that. So I'll talk a little bit about evaluation matrix later on. But definitely for professional users, what I did was very useful to me, share the results. And there was a guy in Sao Paulo, Danilo Neto, who contacted me and wondering if I could maybe do something similar for corporate corpus. He was global AI director at AB InBev, Fortune 100 company. And so I did some consulting with him for a number of months and tried to implement a version for AB InBev for a particular part of the corpus that was dealing with machine learning, AI, and stuff like that. So what I noticed is that there were strong similarities with the Wolfram corpus, in the sense that it was well organized. There's categories, tags, breadcrumbs, and stuff like that. Even the format of what I was getting from, so it came from a database in the case of Wolfram, as opposed to the internet. So sorry, for AB InBev, it was coming from a database. But anyway, what I was extracting, and I'll show an example from the database, was text. Well, there were images and stuff like that as well. So mainly it was text, and in a format that was very much like JSON. And I'm saying this because the Wolfram website was very much like JSON. And then later on, when I processed PDF repositories, for instance, from NVIDIA, I turn the PDF into JSON, and so essentially created some kind of a generic architecture that the base format is very much like JSON. So anyway, I worked for a number of months with Danilo in Sao Paulo. I was working remotely here in Seattle. And eventually we joined forces, and so we created BondingAI with Danilo, who is the CEO, and myself, the chief architect. Then, later on, because everybody is interested in chat and text response and this type of response, we added actually a final layer to our XLM, which turns the structured output into traditional, like OpenAI response, much less wordy. If I have time, I will explain that the more wordy, the more nice words you add and stuff like that, the higher the risk of hallucination. There are problems that come with when you try to reword the original text a lot. I mean, in some cases, it's very useful if you write an essay or something like that, and in some cases, there can be some problems. But so anyway, so we have now a full architecture with the structured output, with chat conversation that are possible. And I will explain more the difference between both. And currently, to generate the response from the structured output, we are actually using small deep neural networks, but there are some other possibilities that we are looking at. So we're not anti-deep neural networks. I want to mention that. And if we can use them, we will use whenever it's in an optimum way, without having billions of tokens or parameters, since we're dealing with corporate corpuses which are much smaller. So that was a little bit of history and context for what I'm going to talk. Now, this presentation, it's broken down in a number of different parts. An introduction, talking about what TCO is, an example of how you can optimize the costs. Then I'll be introducing the XLM framework that I just mentioned. I'm going to share a little bit of sample code. I probably won't have much time to go through it, but mostly when looking at the code is to tell there are many components, and many are related to database in the end, and it's where the database are used and stuff like that I will show in the code. And then I'll provide well, I will share some conclusions and references, and then you can ask questions. So regarding the first part, I'm going to explain what TCO is in a nutshell. Some examples to reduce, the cost in general, and a few challenges which make it more difficult than it could be to achieve these cost reduction. So what is TCO? So TCO stands for total cost of ownership, and there are many different components in TCO that are important, where there's a possibility to optimize and reduce costs. The first obvious one is the acquisition cost, when you purchase hardware of software. And there's the implementation cost, installation, configuration, integrating with your current systems, infrastructure cost, like data center, power. I'm mentioning power here because one of the things, particularly in countries like in Europe, that our system shows people like our system is because we're using very little electricity, because we're using very little GPU and training. So that's something that is valued in some places. And there's operational costs like licensing, cloud resources, GPU that I mentioned, API calls that you have to pay for most of the time. Then there's the maintenance, the support, updates, technical support, indirect cost. I will be talking about that also a little bit. Performance inefficiencies, training, not only training a deep neural network, but also training staff to how to use the system. And actually, for instance, intangible cost related to that. It's related to hiring employees, productivity of employee, or lack of productivity if it's not properly implemented, and then compliance, risk, security. If not properly executed, it can increase the cost. Now I'll start to give a few examples of TCO reduction. I will start with stuff that I've done in the past to significantly reduce cost linked to database use. In the past, I was a BI guy, and I did a number of things, essentially working with lots of SQL and databases. But I'm going to share with you a few examples of what I've done in the past. So there was a job when I was paid to create a list of 100,000 commercial keywords. So, it was in advertising, selling keywords like Google, this kind of model. And after a while, looking on the internet, I found an API from Google that was doing the exact job I was supposed to do. I share with the CEO, I mention it, and from there, we adopted it. So instead of paying, well, I still continue to work for a while and doing some other stuff, but we saved a lot of money. We didn't have to create what I was supposed to. My work was replaced by this API, essentially, which is a big saving for the company. There's another example where I was in a company and working with lots of BI analysts that were spending their days doing a lot of queries, using dashboards that were extremely slow. One of the things I did, I worked with a few of them. I created some kind of a little, very basic interface where they could actually enter a SQL query. The query could have been created by the dashboard, but instead of running it through the dashboard, they would run it through my little application, which was directly connected to the databases. It was more like in production. It was anyway, it was 10 times faster. And this was possible not because I was smarter. Well, I knew a little bit more. I was a BI guy, but BI guy with a strong tech background. But the main thing was that I was had very good relationship with the IT team that let me create this little environment for those BI guys that they could run SQL queries for Python script. I mean, they were Perl script back then, and that was much faster. So the point, the interesting point here is if you have a good relationship between the IT team, you're the bridge between IT marketing, for instance, you can make things happen that are going to really accelerate things in your company. Another thing that I've done in the past, also when I was a BI manager, I was supposed to produce reports like everybody with a little bit of analysis, cleaning, sending emails, highlighting important stuff. And I fully automated that with cron jobs. My boss noticed that I was not working a lot because, I mean, this stuff was essentially automated. Still, he was happy with the results. It would even work when I was in vacation. And even to this day, there's still a lot of people who do those, analysis, the cleaning that can be automated. I mean, there are fewer and fewer. Companies are trying more and more to get this stuff automated, but it's still done in some companies, and this is a place where a lot of money could be saved. Now, the big issue is how do you find a guy, how do you hire a guy who is going to tell his boss, hey, I found a way to automate my job. I can work an hour a week, and it's almost impossible. Nobody's going to say that because people are going to be afraid to lose their job. So you don't do that. Normal employees not going to do that. So how do you realize that there is so much potential savings if the employees are not going to tell you because they want to preserve their job? There might be ways to do it by hiring external consultants. In two of the companies I've been working with, NBC and eBay, I know that they brought in at some point external consultant that did some analysis of where cost could be saved. So that was just a little bit of history of how things started with me on being lean and automating the jobs, and being lazy in a positive way, in the sense that I tried to automate everything I could. Some other examples of TCO reduction. So in many companies, we're working with a siloed database, and here I'm not going to criticize whether it's good or bad. That's not the topic. But the fact is that in many companies you have information stored in multiple databases or repositories, website, and stuff like that. There's not really anyone that knows where all the information is stored. And an example that I wanted to mention here, I was using so a financial company. I was trying to pay someone using via that financial company. I knew how to get paid. I didn't know how to pay someone, and I spent an hour on which looked like a homemade LLM, asking tons of questions. Even in the end, how do I issue a ticket? How to talk to someone and stuff like that. I wasted an hour of my time. And my conclusion was that what they designed, the LLM, was not necessarily bad. I mean, a terrible LLM could have answered that question. Actually, I found the answer on Google eventually. So what happened in this case, what I suspect that happened in this case, is that the LLM that they've designed did not connect to all the components, to all the databases. They were missing essentially some parts in the corporate corpus, which means, for instance, question related to how do I pay someone, I mean, they didn't have any answer. It was made worse by the fact that rather than saying we don't have an answer, it actually output a lot of stuff that was totally irrelevant. And it's also made worse. It was worse by the fact that at the end of each question in the chat application, to ask you for did you like the answer or no, and obviously I say no, and you get, for such a basic question, you get no, we didn't like the answer from a bunch of users, and nothing is done about it. I mean, if there were people looking into the feedback from the user, they would realize, well, there are a number of questions, the same question, we always get negative feedback, and do something about it. So that's something to keep in mind as well, to improve, reduce the cost with LLM for, yeah. Poor QA, that's actually related to the previous example, where you get feedback from users, you're not taking into account this feedback, you're not doing enough testing before it goes live, you should have, like synthetic prompts or large number of prompts that you're going to test before releasing this stuff. And even when it's released, you need to continue to have those tests. And we also have that in our company in BondingAI. I sometimes need to jump in and say, hey, this question does not provide any answer. Why? I mean, so that's something that's important, doing an appropriate QA. Something is to do with common sense. If you are dealing with corporate corpuses, why do you need a model with 40 billion tokens or parameters? So a token is a small part of a word, like machine learning, ink, maybe a token, learn, maybe another token. The English vocabulary, a normal person knows about like 30,000 words. Now, if you work with a corporate corpus, you might have a lot of product names, cities and stuff like that. I mean, it can easily grow to 1 million, but why 40 billion? So common sense tells you it's way more than it's needed. And you also need to know that actually, because most of them, they use transformers, they use deep neural networks, and deep neural networks work well with oversized redundant parameters. So if you have a lot of garbage, a lot of noise in your deep neural networks, it actually helps because it provides more leeway for deep neural networks to eventually get an optimal configuration by going from one point in the parameter space to another one that's produce poorer results. Maybe but then it allows to go back up into all this noise in the parameters actually allow deep neural networks to perform better. But anyway, it's a great fundamental question to ask: is there a way to do with much less than 40 billion parameters when we do know that the number of words that we're going to find in this corpus is going to be smaller by at least 1,000 or 10,000 less. Not properly leveraging AI. So that boils down to some conversation I had with some people, like for instance, when you write code, you get, I mean, some people complain, oh, the code that I get from OpenAI or from some other tools looks nice, but then I need to debug for hours and days, and actually it takes more time than coding myself. And I think that's not the right approach. I found, I'm not a code genius by any means. I'm a decent coder, but my job is not coding. And I found that OpenAI and some other tools are actually very useful. You need to be aware of issues and then ask AI, well, there's this issue in the code that you generated. How can you fix it? And then AI can fix it. So I give you an example. I was asking AI to create a generic Gaussian mixture model, which so I got the answer very quickly. I got Python code that worked, and I realized that it was creating so covariance matrices that are involved in these models that were not covariance matrices. They were not symmetric. They were not. Still, the code worked. And then I asked, can you generate covariance matrices that are actually real covariance matrices? Took 1 minute to do it. I blended the two parts, and I got something that worked in 1 minute. So the challenge here, and people talk to me, hey, Vincent, well, you know how it should be. You're statisticians. You know those things. So you're not going to face these issues. You know what the problem is. You ask OpenAI to fix it, and then you get it fixed. The problem is if you are working with developers who don't have this knowledge, how do you so it's finding the candidates that have this knowledge. And I've been thinking, actually, it would be a good interview question to ask this question, and ask the applicant, use AI to answer that question, and then you check whether the applicant notice that there's a problems, and is then using AI to fix that problem. These days, there are a lot of hiring managers still hate when people use AI to solve the coding question, but I think in the future we're going to move more and more in hiring manager and job interview questions, requiring people to use AI and see how they deal with what the output they get from AI, because it really can save a lot of time when you use AI. Well, the challenges, especially in US for a long time, in bigger is better. We're moving a little bit away from this mindset. Actually, part of the topic, part of the title in this webinar was doing better with less, and that's something I've also been doing a lot. I wrote article with that, for instance, doing better with less, LLM 2.0 for enterprise. It's a problem that's more pronounced in US. Part of it is because there's more money here, so if there's a problem, we can just throw more money to fix it, as opposed to more difficult approach, which would be how are we going to do with less. Another issue is for executives. The performance is usually going to be measured by for career growth. The performance, number of employees, budget size, and stuff like that. So there's an incentive to hire more and more employees for an executive, because how many people report to him boosts his ego, but it also boosts his performance. I mean, it's valued as something positive, and I think, and maybe something to think about it, and that might not be the something that you want in all circumstances. And myself, I'm the other opposite, the other extreme. I don't have a boss, or I don't not have someone asking me to hire a ton of people. And so in my startup, I folks, we try to automate as much as possible using little or no GPU with folks in India, in Brazil, in Australia, with a burn rate that is much smaller than a typical than a competitor, probably like 7 times smaller, or something like $30,000 a month as opposed to $200,000 a month. It makes it a little bit more difficult to raise VC money, because you can't justify 2 million ask from a VC. Another thing that I wanted to add is that we're still currently in AI infancy, and I've been for a lot of different cycles. Sometimes I compare what we are seeing now with what happened in 2000, around 2000, when with Google started to make a lot of money selling keywords, selling clicks. Back then, it was you pay by the click. That was the business model, and it created it boosted the number of clicks. I mean, trillions of clicks were generated, like the trillions of parameters in deep neural networks these days. And then the cost of the click went down and down and down, because the quality was really low. But eventually, the things change, and these days, I think there are a few companies that still charge by the click. You charge by performance, conversion, leads, stuff like that. So I'm mentioning this as an analogy to what is going on right now. There's still many AI companies that charge by the token, or weight or parameters. Tokens and parameters are related in the sense that if you have 10 billion tokens, you might have 40 million parameters. So there's an incentive to use more tokens than necessary, garbage or noise. It inflates the number of tokens, make things more expensive for everyone, but there are companies that are moving in a different direction, and this is our case at BondingAI. Not charging by a token, but by usage, and we try to minimize the amount of infrastructure that is needed. Like, we don't have 40 billion parameters. We have at least 1,000 less to 10,000 less, and so obviously there are cost saving that show both for us, both for the customer. Less electricity being used and stuff like that. Regarding some other challenges, investor pressure could be one of them, where your stakeholders that are forcing you to adapt AI as fast as possible because of competitors doing it and stuff like that. And those investors might not be all the time very knowledgeable about best way to do it. There's some kind of urgency, and when you do things too fast, well, you make mistakes. Marketing influence is another one. You hear, so companies like OpenAI or NVIDIA, they have gigantic marketing budgets to convince everybody that this is what you need to use. There's no alternative. With everything you need. Like, to give you an example, NVIDIA, which sometimes I call it the king of all this environment, and I can only say good thing with NVIDIA because I'm actually a partner of NVIDIA. But they do have an inception program for startups. They have 20,000 startups that enrolled, that they accepted in the program, and they offer all these startups like $200,000 or $300,000 worth of free GPU for 2 years. So you get addicted to those GPUs, because I mean, if you have this GPU power, sure, you can do much more things. You really get addicted to it. And After 2 years, I mean, if you're still around as a startup, you have to pay for it, meaning you're going to charge your customers. So that's kind of the business model that's behind the scenes. That one of the reasons there's so much GPU usage when it might not always be necessary. I won't spend much time because I see it's already 10:40 right now. I won't spend much time on hiring issues. But definitely it's a lot of money that's been spent in hiring, a lot more than necessary. Like people wants to hire engineers who worked at OpenAI. They may be very very costly. Now there's also an issue with H1B. I'm not going to talk about politics. I never talk about politics. It's not saying if it's good or bad, but what I'm going to say is that ourselves, we are hired directly in like India, in Brazil. We can have employees create their own one-man company locally in India and pay them for the company. And it's a way to do it. I think not everybody is aware of how to do it. Maybe you need to do a search on AI. How do you hire directly people in India? I have a very large network, so for me it's a lot easier to find the right people everywhere in the world. Having some sexy stuff in what you're doing is also going to attract more candidates. If all what you're doing is very mundane things, and myself is the same thing. I mean, well, the bread and butter is based on very mundane stuff, or optimizing database performance and stuff like that. It's not very sexy, but if you have a few more sexy stuff on the side, like for instance, in our case, we got predicting art attack, which is one of the agents in what we're offering, deep neural networks, watermarking, that kind of technology, and allow employees to work a little bit on those things. Like Google used to do that in the past, like you spend a day out of 5 days working on your favorite project. I think 20% of the time is too much, but yeah, having something to attract a great talent. Also having an advocate that talks about your company, that's well connected, not only to attract clients, investors, but also employees. Something that would be very helpful. Let's move now to the next section about going more into the detail about our architecture, and then some more key elements to reduce TCO. So I will focus a little bit on this diagram because it shows a lot of important components where the database are to be found, and some of the stuff. So initially on the top left side, you have the corpus, which could be databases, it could be a PDF repository, websites, or combination of everything. From the corpus, you do some chunking. In our case, it's hierarchical chunkings with smaller chunks and bigger chunks. You retrieve contextual information, and with enterprise corpuses, most of the time that contextual information like title, categories, and stuff like that is actually right there in the data. So you don't have to create it, you just have to extract it. And in our architecture, so we extract those things and create a number of what we call the backend tables and parameters. So that's the first part of the architecture. Then on the front end, which is the blue box at the bottom, you have the prompt. Like in every other LLM. We actually have a fairly sophisticated UI, and a nice UI that's more like a browser. It's not just simply a prompt box. I don't have the time to go into all the details, but anyway, You can play with parameters, fine tuning in real time, stuff like that. Do broad match, exact match, negative keywords when you search by recency, putting more emphasis on most recent article and stuff like that. Comes with relevance score, lots of things. And then you also have what I call the structured output initially, which is summary boxes with precise references to your corpus and exact wording as in the corpus. And you have the option to have the standard response. You can choose between both. The standard response being, like kind of a chat conversation like OpenAI. So in the prompt, there's also a number of parameters associated with it. We use stemmer, dictionaries, and stemmer. In 5 the time, I will go in a little bit into the detail about there's some redundancy in our tables. And you say, well, you're trying to optimize the cost, reduce everything. Why do you introduce suddenly redundant table? I have the time to explain the details. There's some redundancy actually helps. What else? Yeah, there's a cache, which is an important part. I'll briefly talk about that. Agents, that's something separate. I'm not going to talk about agents at all here. And how do you connect the UI, the front end with the back end? So there is in the middle column on the top, you linked the prompt to the back end by introducing a small copy of the backend tables, which I call the local the front-end tables, exactly the same format as the backend tables, but they are much smaller, just focused on prompt. I call them the front-end tables. There's a lot of distillation also I'm going to talk about in various layers. Yeah, so I'm going to talk about it shortly. So this is another version of this diagram with more details. I'm not going to have the time to go into the details. The general architecture, this is an example of a chunk actually coming from a EB InBev corpus. So it's coming straight from the database. It's a database record. That's what it is. And so you see the fields that are here. There's a lot of contextual fields and timestamp, category, stuff like that. Then here I'm sharing an example of a query that I did on one of the corpuses for the NVIDIA PDF documents. So the query wanted to know what's the NVIDIA CEO compensation. That was the prompt that I entered. Got quickly analyzed. You see that I'm using stemmer. I could use a synonym as well to enrich the prompt in case the word that is in the prompt it's not in the corpus, but in the corpus you have a different word that means the same thing. So it retrieved 19 chunks, which are pieces of information from the corpus. It could be a database record. It could be part of a PDF document, a PDF page. Actually, it retrieved a lot more than 19. It would probably like 50 or 60. And here it says 19 because there's been heavy distillation taking place. I'm going to explain how it works, limiting that number to only 19, which is also part of TCO, because when you get those chunks and you want to create a final response, instead of creating that response based on 50 chunks, you create that response based on 19 chunks. So that's another way to optimize. So here it shows now the top chunks that was retrieved. So the first column ID is the chunk ID. You don't need to understand all the details here. There's a rank. So I rank each chunk that's going to be displayed to the user in the structured output, or that are going to be turned into a text response. So I rank them, and I will use the top ones. It shows also the size, number of bytes of each chunk, which PDF document it comes from, which page on any particular PDF, and which multi-tokens were related between your prompt and the document in question. We use multi-tokens as opposed to tokens, or multi-tokens combination of multiple words, which is also one of the reasons we have much fewer than other system. And then this, one of the chunk, just give an example, was retrieved, and you get that answered, or CEO, NVIDIA CEO made 23 million in compensation. I assume this does not include stock or stuff like that. And that's anyway what's in the public document. So I'll try to be quick here about key elements that I use to reduce TCO. So there's the mixed RAG LLM approach. So initially it's more like a RAG, but because we also use a response generator, it's RAG LLM combined. Because of that, for the response generator, we only need a small deep neural network. So we also use various distillation technique. To give you an example, general example of distillation, something I've done in the past, they were long ago, some data set, a training set, I randomly removed 80% of the observations, just randomly, and I got the same predictive power. It barely changed anything. Now it depends on the kind of algorithm. That's what for simple regression, and in simple regression, it did work well. For deep neural networks, it's more complicated. If you want to remove, 50%, half of the weights, half of the parameters in your 40 billion deep neural networks, it's more challenging, but something we are working on, and you can try, statistical randomly removing, but different way of removing it. I don't have the time to go into the detail, but so there's distillation at the deep neural network. If you use a large deep neural network, that's possible. There's also distillation that we use when selecting chunks to display to the user. If, for instance, there is a chunk that's related to a keyword AB, so BAB are two tokens, or ABC, we're going to show AB, we're going to show ABC, so it reduces, you're just simply removing a lot of information before even creating the text response. Like I mentioned, so we don't have initially, so there's no GPU, there's no training, there's no black box. You avoid hallucinations, at least in the structured output. I mean, you can have hallucination in the corpus itself. You can have tables that are outdated and stuff like that. But we also use relevances, not only relevancy score, but trustworthy score. So we've used different sources like Wall Street Journal, Reddit, Facebook, Wolfram. We assign a score to each of these sources. And then even on Reddit, there are millions of users. Some write good stuff, some it's a lot of garbage. So these users also get a score, and based on those scores, you create trustworthiness a score that you can share with the users. You only have 6 minutes left. So cache, I mentioned cache optimization. So everybody knows what cache is and know that it's one way to make things run faster. You need to be aware that you need to find the right balance of cache. If you use too much cache, and if the cache is on GPU, and if it grows over time, it actually can be worse than less cache. So there's some kind of an optimum there. Another things I was reading on LinkedIn that and actually I've had that problem myself too, is memory leaks, especially when you write Python code and then you do not do it very well. You might not notice because it's small leaks. There's memory that get blocked and actually is available, but you cannot use it, and it decreases over time. And rebooting the system clear the things, but you need to find a mechanism much better than rebooting to identify where it's some memory that is lost, that inaccessible, that actually is available. Documenting your processes, it can save a lot of time with good documentation of index, glossaries, tags. You can even have a LLM that is going to crawl your documentation to provide the answers about all your processes and stuff like that. I mentioned a little bit of a table redundancy. This seems to be like a counterintuitive, but we do have some tables, for instance, that map a chunk to the parent chunk. What we do, we have the reverse table for a parent chunk that are going to list the children with multiple examples in our architecture, where we have both the table and the reverse table. And in the end, you need to test, of course, to see where you gain when it provides a benefit. But we've found benefit in a number of cases. Reproducibility, nobody cares about that. Nobody's heard about it. So LLM these days, I mean, maybe it's important to you. It's important to you that you try 2 different sessions and you expect to see the same answers. You should not forget about redundancy and discuss that with your team if it is some importance to you. Evaluation metrics. How do you evaluate the quality of your LLM in this case? I mean, a lot is still based on an LLM as a judge, so you use other LLMs to evaluate LLM. I mean, there are problems with that are obvious. There's an article that I wrote, benchmarking XLM and special language models, new approach and results. There's a link at the bottom of my presentation where you can access it. Optimize algorithm, it's pretty obvious. In my own architecture, things were working fine until I got with very large chunks. Sure, the chunks were too big, but because there was some algorithm to create a table of correlated keywords, they were somewhere there was a nested loop, a loop on one keyword and then another loop on the keywords to create a multiplication. Was very slow, and so I replaced that. I found a bottleneck. It was easy to find the bottleneck and figure out a solution to avoid the nested loop. Quantization, something we're not using it because we have so little. Our number of tokens is much smaller than others, but this is used quite heavily in many systems, that you replace 32 bits parameters or weights by 4 bits. Even there's algorithm for fast nearest neighbor search, particularly in the context of vector databases, and SingleStore has a lot of experience with that. Have a database used quite extensively with these particular features. The source code, it's there in the presentation, and I'm happy to further discuss if you're interested, but I won't have the time to go through it. And so yeah, for the conclusion, so these are the topics I mainly discussed about. Reduce GPU consumption, switch back and forth between GPU and CPU, paying by the usage, not by the token, distillation, leverage AI, good documentation, optimizing the cache, security, compliance, evaluation metrics. And I think there's only 1 minute left, so I need to stop here and want to thank you very much for your attention.
All right. So, Vincent, thank you so much for such an amazing session. This was really insightful. So, folks, we are officially, I know like we are kind of out of time, but we are officially open for questions and we'll be happy to do a small Q&A session. So, Vincent, we already have a question from Mark. For anyone else that has like any other questions related to the session, this is like now's the time to ask. So, like, are you able to access the Q&A button right now? Like, or do you want me to read out the question? It's actually a bit of a lengthy one. So,
Say it again.
do you want me to read out the question, or like you can access
Oh,
the?
let me check the chat. Would it be in the chat?
No, it would be in the Q&A console. It's right next to the chat.
Or maybe you can read the question, it might be faster.
Yeah, okay. So the question from Mark is, they say large language models are so rapidly advancing in their capabilities and reducing in cost. Is it a good ROI and opportunity cost to spend engineering time on custom TCO reductions that you recommend? In a few months, the LLM advancements may negate the cost reductions. What do you think? Are there any benefits to consider, like running small LMs on edge devices or offline?
Uh, yeah, so SLM can be small language model, can be also, I see them more specialized language model. I like better this presentation. Whether they can be built on edge, I'm pretty sure our architecture would be amenable to, like uh, on cell phone. But I've also heard some other folks interested in uh, IoT or sensors. How do you get some LLM, a small LLM, implemented on sensors to, and there's definitely a potential out there, and there's been an interest from a few people I've been talking to there. In our case, for instance, uh, we're not so something I didn't discuss here is that I have my own local environment where I do my research, my testing and stuff like that, and it's really does not use standard database, use less nested hashes and stuff like it. It's extremely fast. It's actually a LLM in real time. The training is in real time. And changing the parameters and stuff like that is an immediate effect.
All right.
Not sure. Yep.
All right. Sounds good. So, I don't see that any other questions have come up, and we are, oh, when one question just popped. So, we have a question from Raleigh. She says that will this presentation be made available? So, Vincent, you'll be open to sharing this presentation, right?
Yeah. Yeah.
Awesome. So,
And there's a lot more. Actually, the problem I have, I produce too much documentation. I know that, and people get confused. There's a sea and ocean of documentation. I'm working on that to simplify. There are even books that talk about it. A GitHub repository that is probably a little bit confusing. It's too big. So, but happy to help with guidance on the documentation, the huge documentation that we do have.
yeah, absolutely. Like, folks, we will also be sending an email, like, which will be a follow-up email. So that will have the link to the slides, and it's going to have all the resources. I'll try to, list the resources from Vincent's slide deck and put it alongside in the email so it's easier for everyone to access. So
Yeah.
that would be good, I think. So,
Yeah,
yeah.
and a challenge with all the startups like that is that there's new stuff coming like pretty much like every month. So it's kind of hard to manage. I mean, versioning and stuff like that. But anyway,
So you have, I won't say it's a question, it's rather a comment again from Mark. They say that thank you, Vincent and Yukti. I really appreciate this talk and Vincent's blog and LinkedIn post. So kudos to you, Vincent. Uh yeah. So I don't think so there's anything else right now until something just pops up. So we are almost 4 minutes over time. So I think it's okay to wrap the session. Like, do you have anything else to share, Vincent?
no, I really talk quite a lot, and I know everybody is, including myself, a very busy schedule, so I don't want to eat too much of the time. But thank you very much for attending, and happy to answer, a follow-up question later or provide more documentation and stuff like that.
All right. So, thanks, Vincent, for your time and energy. Like, this session was really, really insightful, and I'm like really hoping to do more in future. So, folks, stay tuned for that. We have amazing sessions that are also coming up in the future. So, you can check out our events page. Like, there's a section that states webinars. So please go on that, and like, if there's any topics that interest you, please hit our SVP, and I'll hope to see you all there. And yeah, thanks for your for your attention and all your energy and time. We are almost 5 minutes over time now, so I'll try to wrap this up really quickly. Thanks, Vincent, and for everyone that attended, thanks for sticking around and have a great rest of the day. You'll receive a follow-up email with the recording and all the materials. So, all right. So, thank you so much. Take care.
Thank you. Bye-bye.
Bye.